Hello everyone, welcome to my YouTube channel. So today I am going to discuss about an interesting problem from topology from CSI and NET December 2023. Okay, so let's start. So the question says that I'll mention the ID in the video description. Okay, so you can just download the paper and match the ID. I'm not going to write the whole question because that will take much time. So consider R2 with Euclidean topology and consider Q2 subset of R2 with subspace topology, and which of the following statements are true. Okay, so the first statement says that Q2 is connected. So first statement says that Q2 is connected. This statement is true or not. Okay, so a basic result from basic metric space that continuous image of connected set is connected, right? So it's a basic result that continuous image of a connected set is connected. So Q2 is connected, right? Now consider the projection map from Q2 to Q. Say x comma y goes to x, right? So projection map is always continuous. So its image of pi of Q2 is Q, right? And we know that Q is not connected. Q is not connected. So that will imply that Q2 is not connected, because if Q2 is connected, then its image Q is also connected. But we know that Q is not connected. Why Q is not connected? Because in R any connected subset is an interval, but Q is not an interval, because in between any two rational number there is many irrational number is also there. So that's why Q is not connected. So hence this statement is false. Now come to the next part. So next question says that if A is any non-empty connected subset of Q, then A has exactly one element. So basically it is asking that what is the cardinality of the component of Q2. Okay, so let A subset of Q2 be any connected subset, any connected set. Okay, and consider the same projection map from Q2 to Q. Since A is connected, that means pi of A is also connected, right? Now if A is not singleton, that means there exists some 2 points in A such that P not equal to Q. So let P equal to x1 y1 and Q equal to x2 y2. So that means at least one coordinate of P and Q are different, right? So without loss of generality, assume that the first component, right, the x coordinate are different, right? So then consider the projection map onto x axis. This, the map is x comma y goes to x. If y1 not equal to y2, you can consider pi y, that means projection on y axis. Okay, so this then pi x of P is x1 and pi y of Q is x2, right? And x1 and x2 both are rational number because the map is from Q2, right? And since A is connected, that means pi x of A is also connected. And any connected subset of Q is singleton. That will imply x1 equal to x2, because we know any connected subset in Q, is singleton. Why this is true? Because connected means it is interval, right? And if you took any 2 points, in between there are infinitely many irrational number. So that's why only connected subset of Q is singleton, right? So hence x1 equal to x2. Similarly, you can take the projection map on y axis and you can show that y1 equal to y2, right? And that will imply P equal to Q. That means A must be singleton, right? A must be singleton. So this statement is also correct. Now the third one says that Q2 is Hausdorff. This is a general fact that any metric space is Hausdorff. Any metric space is Hausdorff. Why? Because say you take xy belongs to x, d, okay, d is the metric, then you can consider distance of x comma y. Since x and y are different, first assume x and y are different, that means distance of x comma y, say delta, that is strictly greater than 0, right? And then you can take distance of xy by 2, which is delta by 2, and you take bx comma delta by 2 intersection by comma delta by 2, that is empty, right? Because x, the delta by 2 radius ball around x and delta by 2 radius ball around y, this intersection is empty, because if there is some element that will imply that distance of x comma y is less than delta, which is a contradiction, right? So that's why it is empty. Hence any metric space is Hausdorff. Now here Q2 and the metric is Euclidean topology is given by the usual metric on R2, right? So that's why the subspace topology given on Q2 is basically given by the subspace metric induced by the usual metric on R2. That's why Q2 comma that usual metric on the subspace metric is Hausdorff space. That's why since any metric space is Hausdorff, in particular this is also Hausdorff. So that's why third option is also correct. Now come to the fourth one. The fourth one is also same, and the idea is also same like proving connectedness. So the fourth one says that the space x comma y in Q2 such that x square plus y square equal to 1 is compact. Okay, so consider the same pi x from Q2 to Q, the projection map. If that is compact, then continuous image of compact space is compact, right? Continuous image of compact space is compact, right? And here the image, here the space is this intersection Q2, right? Say this one is 1, this one is -1, this radius is 1, this is the 0 0, it is 1 comma 0, it is -1 comma 0, it is 0 comma 1, it is 0 comma -1. So this is the space, and it is asked that whether this space is compact or not. So we are going to take its image. Okay, so take its image under this projection map. That will give us -1 comma 1 closed interval intersection Q, because we are taking this space in Q2. That means we are taking this space in R2 intersection Q2. So its image is -1 comma 1 intersection Q, which is not compact. Which is not compact. In particular, why this is not compact? Because we know that compact implies complete in metric space, right? Compact implies complete. But here it is not complete, because you can take a rational sequence that converges to irrational sequence, right? So irrational that converges to some irrational number. That's why it is not complete. So hence it is not compact. So since it is not compact, that means this space in Q2 is not also compact, because if this is compact, then its continuous image is also compact. Hence option 4 is also wrong. So option 2 and 3, these two are correct. Okay, option 2 and 3, these two are correct. Okay, so I'll mention the ID in the in the video description. Okay, so I hope it is clear. If you have any doubt, just comment below. Thank you.